my people, good morning, everybody. I want to use the opportunity to showcase some of the instrument devices we use in our oil and gas industry, in our brewery industry. I want my people to really know how to identify when you see this instrument as a first timer, so that you can be able to identify them. These are the instruments we use. So the first one I want to show to us here is this, with continuation from yesterday class. It's our decay board. This is a resistance board. So we use it to generate resistance value to our transmitters, so that if we connect it to our transmitter, it will generate resistance, and the transmitter will be seeing the resistance as temperature, because it's just like our sensor. Our element generates from the process. The heat that our element generates is being converted to resistance value, and the resistance value is being translated by our transmitter to degree centigrade that we see. We also have other kind of temperature elements like a thermocouple. When you put the thermocouple in a thermoware or in a ware of process pipe, the thermocouple will be generating millivolts. Our transmitter will translate that millivolts to temperature in degrees or in Fahrenheit. You see it on your transmitter. So this is our resistance bus. This height is from this value is from 0 here to 10 ohms. 0 to 10 ohms. You can see it. 0 to 10 ohms. If you want to make your resistance to go to 100 ohms, we have 1 kilo ohms, 10 kilo ohms, 100 kilo ohms, 1 mega ohms step. So all these mega ohms, we have a sheet. We have ohms here, different ohms. This variable you are seeing, as we increase it, as it's moving up, the resistance value will be increasing. These are the cables. We have 3 cables. These are the terminal ports. You can see these are the terminal ports that is being connected to your transmitters. These are the cable from the resistor that is connected to your transmitters. When they are connected to your transmitter, as we increase the value here, the resistance value here, your transmitter temperature will be increasing. As you can see, these are the cable, 3 cables from this particular port. 1, the black is the common, so the common carries two wire, which is the black and the blue, while the positive part of it carry the red. You can see it. At times you have 3 wire. These two now represent compensation and common, while this one is the main exciter of the thermocouple, or the temperature element. So when you increase your resistance value, as these two things are connected to your not now. But for this video, it's just a surface explanation. That is that for this. We have this is our joke. This is our joke, pressure joke. We use this one to pressurize our transmitters. Use this one. This is a joke, pressure joke. If I on it now, you see this is a pressure joke. We use this one, this particular instrument. We use this particular instrument to calibrate to pressurize our sensor. Calibrate the transmitter. You can see this millimeter water. This is the pressure of the pressure unit, millimeter water. So from here you connect this particular tube. Like you can see here, this one is connected to this tube is connected to the joke, and this particular terminal port. This port here is connected to the transmitter. You can connect, this is our transmitter here. This is our transmitter. So you can connect your this thing to your transmitter. This is our transmitter. We connect it to the eye port of your transmitter for you to calibrate the transmitter sensor, pressurize the sensor. So this is our joke. It's also on that kind of joke. It's also on that type. You press, look at it. So you press these two parts. When you press it, you see. When you press it, if you're seeing it, if you press it, I want to cover this port. So you press this place to be generating pressure. See that you see? Generating pressure. So this is our pressure, and we use to calibrate our sensor. Hello, sir. Yeah. We use this one to calibrate our sensor. If I press it now, this one is close isolation. We close this particular place. This is isolation to vent. To vent it. So if I press it now, you see. It's only that it's doing it, that's why I can't do it now. Cannot enter very well, but this is what we use to calibrate our sensor in our pressure transmitter, our flow transmitter, over our level differential transmitter, DP or pressure, anything that has to do with pressure. We use this particular device to calibrate those instruments. So that is that. We also have our communicators. This is a 475 communicator. Press it to on it. You press the power button for a long time to on. This is our 475 communicator. Also have an Emerson Trace communicator. You press, you on it from here. And these are the two instruments. This is our multimeter. This is our multimeter. So our multimeter we use to check our voltage, 24 voltage, amperes, our milliamps value, our resistor value, millivolts. You can use our meter to check it from our instrument in the field. So as you can see, this is it's booting. This is booting and it's coming up. And as you can see, this is a feed communicator. We can use this one to calibrate. Also, to what it normally does, we need to simulate our, but it's not connected now. You can see here, we need to simulate our transmitters, to do loop check it. So from here, if this instrument is connected, they are the same thing. As you can see, they are the same thing. Setting foundational feed bus, setting right here. It's also the same thing. If you want to do your valve link, mobile phone, mobility, feed communicator, if this thing is connected to this instrument, now if it's connected, there's a cable we use to connect it to each other. If it's connected, you only just to come here and press this particular place. Bam, you press it, as you see, it's going. This one is booting. What it's trying to do now is for this communicator, just like our DCS. It's just like the DCS. If you connect to your transmitter, we told every details of this transmitter to be displayed here. It will display on this screen. This is just like your DCS. We show you everything that is in the transmitter. Also, that is the same thing the 475 is doing. This is the 475. This is the 475, and this is our tracks too. Both of them we use them for the same thing, for calibration, for simulation. This is also our loop calibrator. You can see loop calibrator 70 loop calibrator. This is our loop calibrator. You can use our loop calibrator to, as you can see, 25% to 100%. So you can simulate 25, 8, it's changing 4. So it's because it's not connected. But you can use it. You saw it change from 4 to 8. As it's changing, it's showing the milliamp, right? The percentage will be showing here. You can use it to simulate to do simulation of your valve, your transmitters. You simulate 4 to 20 milliamps. And if you open your valve, close your valve, it will. So